but I'd like to cover some of the rules of exponents. Exponents, that's the number on top. If you have 5 times 5, that equals to 5 squared. We just put a little number up there to see how many 5s we have. How dumb, right? Well, it just works out really well. And if you have 5 times 5 times 5, it equals to 5 with a little 3 up there. That's how the exponents work, and that's what they're for, to tell you how many of something is or more information. It's just a way to write it down without having to write down 3 5s. And so, the more you have, so 5 times 5 is equal to 25, and 5 cubed is equal to 25 times 5, which is 125. And that gives you how that works. Well, that is the way that the exponents work. You just have exponents. And so if you have 5 squared times 5 cubed, so you have 5 squared, that's 25 times 125. Well, you can do something really magical. You have 5, and you add the exponents. So when you multiply two numbers that are the same with exponents, you end up adding the exponents together. That would be 5 to the 5th power. And that is how the exponents work when you are multiplying two numbers together that have exponents. If you have the same base, this 5 is called the base, and the 3 is the exponent. This 5 is the base, and the 2 is the exponent. When you have the same base and you're multiplying, you add the exponents, and that's how it works. So if you take 25 times 125, that equals 3125. So 25 times 125 equals 325. Sorry, 3,125. There we go. And that is what that equals. And that is the same thing as 5 to the 5th. So we could write 3125, or we can write 5 to the 5th. It's the same number, and it makes it easier for you to deal with. And that's how it works when you multiply. And you can see that 5 squared is 25, 5 cubed is 125, and 5 to the 2 plus 3, or 5 to the 5th. We could just write it. We could say 5 times 5 times 5 times 5 times 5. We could write it that way. But we've saved time, effort, trouble, and energy by writing it down with an exponent, and then figured out that you can add the exponents when you're multiplying. And it's a fantastic thing. So that is multiplying exponents. So there's another rule of exponents that you need to know, is if you have something to the power. So 5 squared cubed equals 5 to the 2 times 3, which is equal 5 to the 6th. So in other words, you're squaring something and then you're cubing it. And so that means you multiply. You remember that a while ago we had 5 squared times 5 cubed, and that equals 5 to the 2 plus 3 equals 5 to the 5th. But 5 to the squared to the 3rd is 5 to the 2 times 3, which is 5 to the 6th. And those are the rules of multiplying and multiplying exponents and powers of powers. Another thing that you have to understand about exponents is if you have 5 cubed over 5 squared, that equals 5 to the 3 minus 1, 3 minus 2 equals 5 to the 1st, which is just plain old 5. And that's how that works. So whenever you have when it's divided, 5 cubed divided by 5 squared is equal to 5 to the 3 minus 2, which is 5 to the 1st, or 5. How in the world does that work? Does that make any sense? Sure. If you have, let's rewrite. 5 times 5 times 5 is on top, and then 5 times 5 is on bottom. And so you can cancel out. These cancel out and become 1. And when you multiply times 1, it just goes away. These cancel out and become 1. And this is 5 is all that's left. Over 1? Sure. It's just plain old 5, which is what we got up there. So that's why you can subtract the exponents when you are dividing. Now, another thing about exponents is if you had 5, I don't know, that's fine. 5 to the negative 1, that equals 1 over 5, which is, you can just leave it as 1 over 5. Or you can realize that that's 0.2 if you divide it out. And some people write 0.2 to kind of make it stand out a little bit. But if it's got a negative exponent, it is over that. So if you had 5 squared negative, that'd be 1 over 5 squared, or 1 over 25. That's how the negative exponents work. So if you had 1 over 5 to the negative 2, that actually puts it on the other side. That puts it, because if you've got a negative on one side of the bar, it puts it on the other side. So 5 to the negative 2 over 1 becomes 5 squared over 1, basically, which would be 25. It moves it to the other side. And that's important because if you have like a bunch of different exponents, if you have 3 to the negative 2 times 5 squared times 5 cubed times 7 to the negative 2, over 3 to the 6th times 5 to the 4th times 5 to the 6th times 7, whatever. All these with negatives jump to the other side. And if you say, let's put a negative 3 here. All right, so we would actually move these around. So let's draw our line. This 3 to the negative 2 becomes 3 squared, and the 3 to the 6 is still there. And the 5 squared stays up times the 5 cubed stays up. The 7 to the negative 2 becomes 7 squared on the bottom. And then this is times the 3 to the 6th, and times 5 to the 4th, and times 5 to the 6th. And then the 7 to the minus 3 goes up here, 7 cubed. So when you have negative exponents, it makes it jump to the other side of the bar that you're using to signify that it's division. And that is some information, some interesting facts.